All right, so if divers surface too quickly from great depths, the nitrogen that is dissolved in their blood um, and other tissues bubbles out of a solution. So these bubbles can become trapped in the joints and cause great pain, and that pain is called the bends. So liquid, if I take water and I put food coloring in the food coloring spreads itself out through the water. That's called a solution. Well, gases can form solutions as well. So we breathe in a lot of air, and sometimes that air is trapped in our body. Now, when you go way down deep, that changes. Remember that pressure has an effect on things. So when you dive deep under the water, there's a greater pressure the further down you go, and as you come back up, your body has to adjust to that. So divers take a little bit of time going down, and they take a little bit of time of coming up. That gives your body the ability to kind of get rid of that extra air in the form of nitrogen. So anyways, what does that have to do with today? Well, when you hear the word dissolve, you probably think of dissolving things into a liquid. However, any state of matter, whether it's a solid, a liquid, or a gas, can become part of a solution. When you hear things like a metal alloy, that's a solution of two metals. They take two metals, they melt them together, stir it up, and then let it cool. So you can even have a solution of solids. The human body consists of mainly water. Gases can dissolve into the water and form a solution. Nitrogen solubility in blood increases as pressure increases in the depth. So as you're, if you, and you need to give your body natural time to exhale that extra air. So what are the three processes that can occur when substances are dissolved? Well, substances can dissolve in water in three ways: disassociation, dispersion, and ionization. So a solution is homogeneous, is a homogeneous mixture. By the way, this is one of the reading guide questions if you're curious. A homogeneous mixture of two or more substances. Every solution has two types of components: a solute, which is a substance whose particles is dissolved in the solution, and the solvent is the substance in which the solute dissolves. So one is dissolving into the other. A stainless steel pot or pan is a solution of chromium and nickel into iron. In a solution, the solvent is the substance in the greatest quantity. So let's look at some things. You can have a gas solute into a gas solvent. Air is a great example. Most of the air, atmospheric air, is nitrogen, but it has carbon dioxide and oxygen in it. Liquid in a gas, you can have water and air, water molecules in the air. Gas in a liquid, carbonated beverage. You can have carbon dioxide in water. Liquid in a liquid, vinegar. That's acetic acid in water. Solid in a liquid, sugar water. You dissolve the sugar into the water. And then solid in solid, you are technically dissolving chromium and nickel into iron. Now they melt it all, but that's how it's done. Now, disassociation of ionic compounds. For a solution to dissolve in water, the solute and the solvent particles must attract one another. Before a solution can form, the attractions that hold the solute together and the solvent together must be overcome. Sodium chloride crystals, by the way, sodium chloride is what? Do you guys remember? Salt. Yep, you guessed it, salt. The sodium chloride is an ionic compound. Water is a polar molecule and is attracted to the ions in the solute. So the crystal dissolves as the sodium and chloride ions are pulled apart in the solution one by one and by the surrounding water molecules. This process in which an ionic compound separates into ions and dissolves is called dissociation. So the ionic bond between the sodium and chloride is broken, and so you have sodium ions and chlorine ions kind of floating around in between the water molecules. That's called dissociation. Here's an example of it. So you've got water. That's this. Well, this is the sodium chloride. This is the salt, and these are little water molecules. And then what happens is the ions break apart, and then you'll have little water molecules surrounding the chlorine and sodium. And that's what happens when you pour salt into water. Okay? So dispersion of molecular compounds. Now, when you place a piece of hard candy on your tongue, the sweet taste spreads or disperses throughout your mouth. Sugar dissolves in water through dispersion or breaking into small pieces that spread throughout the water. So it's a little bit similar, but I think what they're trying to say is that the sugar remains intact. So here's an example. We have water molecules that collide with sugar crystals. So here are my water molecules. Here's the sugar crystals. What happens is those sugar crystals kind of break up into smaller sugar crystals, and they kind of just hide in between the water. If you dissolve the water, the crystals come back together. Now, the ionization of molecular compounds is a little different. If you think about hydrogen chloride as a molecular compound in which hydrogen atom and the chlorine atom share a pair of electrons, as the hydrochloride gas dissolves in water, the hydrogen proton from each molecule is transferred to the water molecule. So here we have a water molecule, that's this on the side, H2O. Here you have a hydrogen chloride, right? And so what happens is the proton from the hydrogen here moves over there, and now it's transformed. So this is a dissolving. When the hydrogen chloride and water form a solution, the two molecular compounds react and form two ions. The process in which neutral molecules gain or lose electrons is known as ionization. Dissolving by ionization is a chemical change because the solution that results contains new substances. So I should probably point that out. When I dissolve my hydrochloride molecules into water, I get a different substance, H3O, as opposed to H2O and chloride, and these are ions. What are some properties of a solution that differ from those of its solvents and solutes? Well, three physical properties of a solution that can differ from those of its solute and the solvent are conductivity, freezing point, and boiling point. Now, that was one of your reading guide questions, right? So what are those? Well, conductivity, here's an example. Sodium chloride is a poor conductor of electric current. When sodium chloride dissolves in water, however, the sodium and chlorine ions are able to move freely. These ions in the solution will conduct the electric current. They'll carry electrons through the water. In fact, that's how batteries work. Most batteries have some sort of ion or solution. A lithium-ion battery, lithium is a type of salt, right? So lithium-ion, nickel, cadmium, those are ions. And when they're in a solution, they carry the electrons from one side to the other. Properties of liquid solutions. Well, magnesium chloride dissolves in melting ice and snow and disassociates into magnesium ions and chlorine or chloride ions. The magnesium and chloride ions, which are attracted to the water molecules, interfere with the freezing process. The magnesium chloride solution can have a freezing point as low as -15. So, and that's what happens when you put salt on ice too. Very similar thing. The salt changes the freezing point. Salt spread on icy road lowers the freezing point. So, but it only works to a certain amount. Like if it gets really, really cold, the salt doesn't help. One of the things that I found interesting, and it would be very expensive, you couldn't do this, but if you take rubbing alcohol and put it in rubbing alcohol, I can't remember off the top of my head what the freezing point is for that, but it's much, much lower than the weather here in Indiana. So if you were to pour liquid alcohol on the streets, that would melt ice. The problem is the alcohol evaporates quickly. It will dissolve in the water. It's not the most practical thing, but it's fascinating that it doesn't freeze. So there's lots of things to do that. Pure water freezes in a hexagonal pattern. That's because of the polarity of the water molecule. When you put salt in it, or when it's salted with magnesium chloride, the disassociated magnesium and chloride ions disrupt this formation of ice crystals. So remember, we talked about this when we talked about the phases of matter. It becomes more structured, more organized, and this ionization process disrupts that structure. Therefore, it can't form a solid. I mean, it will eventually. It's just at a much colder temperature. The coolant used in most car radiators is a solution containing water and ethylene glycol. Water at sea level boils at 100 degrees Celsius. Adding this stuff together, the boiling point helps prevent the engine from overheating. Because this chemical also lowers the freezing point of water, the coolant does not freeze during spells of cold water. So the radiator antifreeze is what we commonly refer to it. By adding that to the water in your radiator, it prevents the water from freezing. If you just put pure water in your car, it would literally freeze and expand inside the engine and crack your engine. But by adding this chemical in a solution, it lowers the freezing temperature. Now, what happens to the energy when a solution forms? During the formation of a solution, energy is either released or absorbed. So when sodium hydroxide dissolves in water, the solution becomes warmer. The solution releases energy to its surroundings. Remember, we're breaking these bonds in some cases. When ammonium nitrate dissolves in water, the solution becomes colder. The solution absorbs energy from its surroundings. In order for a solution to form, attractions among the solute particles and attractions among the solvent particles must be broken and requires energy. New attractions form between the solute and the solvent particles, which release energy. The difference in these energies is known as the heat of a solution. The solution process can be exothermic or endothermic. Remember that dissolving sodium hydroxide in water is exothermic because it releases heat. Exo means outside, heat means, or thermic means heat, so we're going to release the heat outside. Endothermic, obviously, is when you absorb heat in. So what factors affect the rate of dissolving? Factors that affect the rate of dissolving include surface area, stirring, and temperature. This is very similar to chemical reactions. Basically, molecules and atoms have to come into contact. If we can increase that, then we increase that process. So rates of dissolving depend on collisions between the particles, just like chemical reactions. Dividing a solid into smaller pieces, particles, increases the surface area so it dissolves quicker. Take a big chunk of sugar, like a big sugar block, or if you buy that at a pet store, you know they have these big sugar blocks that you can buy and give to horses, and the horses lick them. Salt blocks are the same way. If you put that in a big thing of water, it'd take forever. It would dissolve, but it'd take forever. But if you take pure sugar and pour it in, not pure sugar, like the table sugar that you put in coffee and stuff, that would dissolve much quicker because there's more surface area. Stirring also dissolves the particles quicker, increasing in temperature because it increases the kinetic energy, because the molecules move around faster, there's more collisions. That increases the dissolving rates. So the rate of dissolving can be increased by reducing the particle size, which creates more surface area, by stirring and heating the solvent. So if you guys remember when Mr. Adams did that evaporation demonstration with the food coloring and sugar, what did I do? I had it stirring and I had heat. Real quick, couple assessment questions. Before boiling water on the stove, you add salt to form a solution. The solution's boiling point will be, it'll be different. The question is, will it be higher or lower? C, higher than the boiling point of water. Okay, and it makes it taste good. If you're making some sort of pasta, you put a little salt in there, you can turn it up on high. It'll boil the noodles quicker, and it adds a little flavor. The process of forming a solution of a molecular compound is endothermic if the solute B forms weaker attractions to the solvent than other solute molecules. How do you increase the speed at which a solid dissolves into liquid? Let's see. Crush the solid into finer pieces. C would probably work. You don't want to cool it. You would heat it up. Applying electric current, I don't know. That would probably mess it up. I think C is the correct answer. Last one. Ionic compounds dissolve in water through the process of dispersion. That's false. It's through dissociation, actually. And that's it. Any questions? All right, cool.